So in this lesson, we're looking at solving quadratics using factoring. And what we're going to look at first are simple quadratics. And these simple quadratics are quadratics that are already formatted to where we don't have to use quadratic formula, completing the square. They're things that we can use with simple factoring. So if you look at your assignment right here on page 235, I'm going to be over in this section working on solving by using factoring and taking square roots. So the first example we're going to look at is number 63. And on number 63, we have x squared plus x equals 0. So what we want to find is all the possible solutions for this particular quadratic equation. What values of x could I put in to give me 0? So the first thing we're going to do is what we've been doing with our other factors, and we're going to look for the greatest common factor. So the greatest common factor that I have between x squared and x is x. So I am going to factor out an x, and that's going to leave me with x plus 1 equals 0. So all I've done now is I have factored out the greatest common factor from my expression. So the question is now, what do? I know that this value times this value gives me 0. Well, factors, when you see the word factor, the factors are values that are multiplied. A factor is based in multiplication. So in order to get a product of 0, that means either this factor or this factor has to be a 0. In order for us to get a 0 as a product, one of the two factors has to have a value of 0. In this case, we don't know. Either one could have a value of 0 and still make the equation work. So what we're going to do is individually set each factor equal to 0 and see what our values are. So the first one, I'm going to set x equals to 0. And you can see that one, that's pretty self-explanatory. That one's done. Because x equals 0, it's pretty simple. There's nothing for us to solve. The second one, we're going to set x plus 1 equal to 0. Then from that point, we're going to solve it. So I'm going to subtract the 1 from both sides. So x equals negative 1. So what this is going to create for us is we have two solutions. So our first solution, x could either equal 0 or x could equal negative 1. And those are our two x values. If you were to plug either of these values back into the original equation, they would both produce a product of 0. They would both produce an answer of 0. So that's one of our more simplified examples. And again, that's number 63. So let's move over to number 65. And number 65 presents us with a little bit different setup. So I have n squared equals 5n. Now there's two different ways you can do this, but since we are focusing on factoring right now, I want to go ahead and move everything over to one side of the equation so that we have a 0 only on the other side. So I'm going to move this 5n over to the other side. So I'm going to subtract the 5n from both sides, and that's going to end up giving me n squared minus 5n equals 0. Now I'm ready to go and I can factor. So again, we're looking for the greatest common factor between our two terms, and in this case it is an n. So I'm going to factor out an n. That's going to leave me with n minus 5 on the inside. And you can see we're already at the same point we were over here after we factored out the x initially. So I'm going to look at my first term, and I'm going to set both of these to 0. So the first one is easy. N equals 0. Just like over here, that's all you have to do. It's already done its own work. The next one is n minus 5 equals 0. We solve it for n, so that means add 5. So n is equal to 5. Therefore, our two possible answers are n is equal to 0 or 5. And those are your two answers. Now I'm going to show you why those answers work. Let's go back to number 63. How do I know 0 and 1 are in fact the two values that will make this expression work, this equation? Let's go up to the original equation, x squared plus x equals 0, and let's plug in our two values. So let's start off with the 0. If I plug in 0 for x, I have 0 squared plus 0 equals 0. And you will see that ends up working. 0 will equal 0. So now let's check the negative 1. So I'm going to come over here, and I can use the original equation, or I can use the factored value, either one. If I were to use the original equation, let's go back to the 0, I would have 0 times 0 plus 1 equals 0. And that would give me 0 times 1, which is 0. So that works. So let's try negative 1 in both equations. Negative 1 squared minus or plus negative 1 equals 0. This will work also because negative 1 squared becomes positive 1, and then we end up with 1 minus 1 equals 0. If we plug it into the factored form, I have negative 1 times negative 1 plus 1 equal to 0. Negative 1 plus 1 is 0, so negative 1 times 0 is 0. So it works. That's how you check these. Same thing over here. And I'm going to plug into the factored form this time. Let's check out 0. Let's go to our factored form right here. This one. Or this one right here. So I have 0 times 0 minus 5 equals 0. Does that work? Yes, it does, because I will have 0 times negative 5, and that does equal 0. So you know 0 is correct. Let's try the 5. 0 times 5 minus 5, I'm plugging in, again, I'm plugging these values in for n, equals 0. 5 minus 5 is, or sorry, that's a 5 out here. 5 times 5 minus 5. 5 times 0 is 0, so that one works. They all work. And that's how you check your answers. So let's move on to solving with one of the ones that we came in with yesterday. So I have in, for example, 51. If you go to page 240, page 240 is part of your solving using the difference of squares. So on page 240, we're going to look at number 51. So on number 51, this is on page 240 of your worksheet, of your packet, we have n squared minus 121. Okay? And that is equal to 0. So the question is now, I look at this and I don't see any common factors that I can pull out between these two. So it's not going to be the same as solving the way we did with the original ones. So what I'm going to do here is I'm going to say, oh, I recognize this as a difference of two squares. This can be written as n squared minus 11 squared equals 0. All we've done is make it an equation. So what would I do from this point is I know how to factor a difference of squares. So I'm going to factor my difference of squares. And I'm going to have my n and my n, my 11 and my 11, and my plus and my minus equals 0. Again, I'm just using the difference of squares to factor. Once I've done that, I'm going to do the same thing I did on the previous examples. I'm going to take this factor and set it equal to 0. So n plus 11 has to equal 0. If I solve this, I'll move the 11 over. That means n equals negative 11. That is your first answer. The next one I'm going to do is take this factor and set it equal to 0. So I have n minus 11 equals 0. Again, I'm going to solve this, so I'm going to add 11 to both sides. So n could also be positive 11. So ultimately, you're going to have two answers, and your two answers for n are going to be positive 11 and negative 11. You could actually also write this in a different format. If you remember when we were doing quadratic formula, it could be plus or minus 11. That's the other way you could write it. And again, if you want to check your answers, take the 11s, plug them back into your factors, and see into this factored form and see if it gives you 0. All we have to do is create a 0 in one factor or the other, because anything times 0 will be 0. And that is solving quadratics by factoring without actually using trinomials. What we may do at times is use trinomials. We'll run into trinomials. We won't have something like this. We may actually have 3 values in our expression. So for example, if I have x squared, this is just going to be an extra example. If I have x squared minus 8x minus 20, that's not something that's formatted or equals 0. That's a quadratic function, just like all of these are quadratics. They're quadratics because the highest degree term is squared. So in this example, I would factor this using either MF DARM, which in this case I don't have to because my A value is 1. I would just do regular plain factoring. So I'm going to pretend that 0 is not there. I'm going to take the 20 and I'm going to factor it. So my factors of 20 would be 20 and 1, 10 and 2, 5 and 4. So following our rules that we've used in the past, I'm going to look at my C value. In this case, the C value is negative, so I'm going to do subtractions here. And I'm going to be looking for a difference of terms here that gives me an 8. So I've got 20 minus 1, which is 19, 10 minus 2, which is 8. That is the one we're going to use. So I'm going to come back over, and I'm going to do my factoring now. I know when I factor and my A term is 1, I'm going to have x and x when it's x squared. So looking at the two factors, I know by what I just did that it has to be 10 and 2. It has to be 10 and 2. The question with that, though, is what are the signs going to be in the factors themselves? Well, you look at the B value, and in this case, the B value is negative. What that means is the largest factor has to have the negative, carry the negative sign. Since your C value is negative, that means the signs have to be different. Remember, if the C value is positive, these two signs have to be the same because the product of this value and this value are what give you this value. In order for us to have a negative number, we have to have a negative and a positive. And you see negative 10 and positive 2 gives you negative 8. So moving on from here, after we've done the factoring, this is equal to 0. Now, because we have factored this, we can actually find our two zeros. So I'm going to set my first factor, x minus 10, equal to 0. When I solve it, that gives me an x value of 10. So that's my first value. My next value is going to be setting x plus 2 equal to 0. And in order to do this, I solve by subtracting the 2, and I'm left with x equals negative 2. So now I have my two answers, or my two values that will work for this equation, and that is x equals 10 and negative 2. And once again, if you want to check your answers, take the values that you got, plug them back into the factored form, and make sure, or you could plug them into the original, it's up to you, and verify that when I plug in 10, I get this times this product gives you a 0, or when I plug in negative 2, this one times this one gives you 0. And that is solving by factoring.